Okay, so now let's look at another question. It's going to be given point P is 1, negative 1, 2, Q 2, 0, negative 1, R 0 to 1. So find the area of the triangle, right? Determined by the points. So that's the triangle. Okay. So we want to know this, but as you can see that when we learned about the cross product, noticing that, so if we said this is a theta here, so the area for this parallelogram, actually it is the magnitude of this PQ, right, times sine theta, that give us the height, right? And then also time the magnitude of this PR vector. So that actually give us this whole area, okay, the whole area. And then if we're looking for the area of the triangle, which is just to the half of it, right? Which is half of PQR. Okay, so that's how do we start? About where we got this? Well, as you may recall, the cross product, let's see, so it's PQ cross PR. That's gonna give you its magnitude, sine theta, right, and then time its unit normal vector, right? So this n is the unit normal vector. So that means if we take the magnitude of the cross product result, they're going to give us exactly this, because the magnitude of this unit normal vector is equal to 1. So this part is just scalar. Theta is between 0 to pi. It's always non-negative, so we don't have to care about this part. So everything is good. So basically, to get this, you need to figure out what is PQ cross PR. Okay, so PQ in this problem is going to be 1, 1, negative 3. Okay. PR, it's going to be negative 1, right? 3, and negative 1. Okay. That's what we got. So IJK, so 1, 1, negative 3, negative 1, 3, negative 1. Let's check. So P, this is 1, 1, negative 3. Okay, good. PR is negative 1, 3. Okay, good. Alright, so we've got this. So R, we're going to have its alright, into this was better. Right, so okay, so we can do negative 1, right? Minus comes into 8i, right? Negative 1 minus 3, so it's negative 4. And then there's another negative, so plus 4j, right? and then so it's a 3 minus -1 becomes 3 plus 1, so it's a plus 4k. So the area of this rectangle, which is just the magnitude of this, right? And then half of it. Square, 4 square, 4 square, half. So actually we can do over 2 square, right? So put it into some bracket. So I have 4 square plus 2 square plus 2 square, right? So that is, so it's the square root of 24 or 2 square root of 6, right? 2 square root of 6. So yeah, that's so how do we handle this? See what else? Alright, so the next question, it's kind of like include everything about the point P, point Q, point R, and point F. Okay. Alright, so the part 1 is find the parametric equations, okay, for a line through the points P and Q. Okay. So to find the equation of a line in space, we need to know a point on that line, and meanwhile we need to know a parallel vector, right, on that line. So that's kind of like how do we do the problem here? So the point is given here, so the parallel vector we can write as PQ. Right? So that is 1, 1, negative 3. Okay. So if you want to write your equation into a parameterized, so it's x of t equals t. If we set the v0 as a p, so it's a plus 1, right? Yt, it's a t minus 1, zt, it's a negative 3t plus 2, so t goes to negative infinity to positive infinity. Okay, so we're talking about in space. Okay, so everything is in 3D. Number 2, we want to know, so find the distance from point R to the line through PQ. Okay, through PQ. So that's so first let's see. Let me give you an idea here. So suppose this is a point R. So this is the line here. Okay. So what we really want is to want to this guy, right? So this is the line. And so how do we do that? Well, the idea is if we put this as a point P here, if I also put this as angle. So notice that this is the vector parallel to this line here. And okay, so the thing is, what we really want is, as you can see, if we claim this distance d, is exactly, excuse me, the vector PR, right? Magnitude of this vector times times sine of theta. Okay, and this again, theta is the angle between the parallel vector and the also the vector PR here. Okay, so how do we drive this? Again, normally I don't like to memorize this formula. What I like to do is to memorize or to understand this this graph better. So I need this guy, and if you recall, what do we get here from the cross product? So the PR cross vector V, it gives us is the PR magnitude sine theta, right, times this unit normal vector here. And if we put this magnitude of this part, so basically we drop to this guy, right? And look at what we want this guy, right? So basically, if we divide it by the magnitude of V, we're good, right? We're good to go. So that's how do we drive this formula here. So noticing that PR, so recall this, it's going to be -1, 3, and -3, right? It's -1, 3, and -1. That's a PR. And a vector V, which we can use the PQ, which is 1, 1, -3 here. Okay. So what I would do here is you just do first a PR cross V, right? And so it's I, J, K, -1, 3, -1, 1, 1, -3. That will give us is let's try to do that one. So this is -9, right? So it's going to give you -8I, right? So it's a 3 minus become +4, and then so it's -4J. And then I skipped this part a little bit because you can refer how do we calculate the determinant of this 3 by 3. And this is -1 -3, so it's -4. Okay, right. So it's magnitude for this. So distance, right? It's a squared plus 4 squared plus 4 squared over the magnitude of V, which is 1 squared plus 1 squared plus 3 squared, right? So what you're going to have here is 64 plus 32, right? 16 plus 16. And then over square root of 1 plus 1 is 2, 11, so you're going to have, so 6 over 11. Okay, so that's the distance check. All right. So the next question, it becomes, okay, still we have this guy, and we want to know, okay, so find the equation of plane through the point of PQ and R. Okay, PQ and R. Okay, so that's what we get. Well, so to find a plane, we need to find a point, right, on that plane. We got that because we have 3, and we also need to have a normal vector, right, for the plane. So you can see, guys, if you recall, what we did here is from the previous one, because this V is a PQ, right, vector PQ, this is PR, so PR cross PQ, actually we can take advantage of right? So, excuse me. So it's P R cross P Q. We can take the advantage of the previous result because this normal vector is actually calculated here, which is -8, -4, -4. And then we can pick the point. Let's see, pick the point of P, which is 1, -1, and 2. So with those two, the equation of the line of the plane, excuse me, is going to be x minus 1, right, times -8, plus y plus 1 times -4, plus z minus 2 times -4 equals 0. Of course, you can simplify. Right, so one thing you can do is if you multiply -1 on both sides, right, so it becomes into plus, plus, plus. And then, so you're going to have 8x minus 8 plus 4. Oh, so this is plus, okay, guys. Bad handwriting. Plus 4 plus 4z minus 8 equals 0. So it turns out we have, oh, we actually can even do better. So it's 8x plus 4y plus 4z. So it's minus 12, right? And we can divide it by 4, so that's going to give us as 2x plus 1 plus z minus 3 equals 0 or equals 3. Okay, so that's what we get. So, okay. So last one we might ask you is, okay, so what is the distance from the point M to this plane? Okay, that's the other question. Well, so this part should be very straightforward. So as you can see, this is a point M, and basically, guys, so suppose this is a point of P here, and this is, of course, this is the, suppose this is the corresponding normal vector here. As you can see that we are looking for the distance between this point and the plane, which is exactly this part. But also, guys, you can see that it's exactly the projection, this PM onto this vector, right? And then it's the what they call the magnitude of that part. So basically, this distance d is gonna be PM, right? And then dot this n magnitude, right? And then over the magnitude of this part. Okay, so that's kind of like for the PM. The vector is gonna be, that's our PM. So it's a -1, 1, -1. That's -1, 1, -1. Our n here is you know that. Okay, so it's good. So this should be extremely straightforward, right? So this is gonna be 8 minus 4 plus 4 over this guy. Right, so 8 over, so you can factor a 4 square out as a 4. You have 2 square plus 1 plus 1. So it's 2 over square root of 6, right? Or square root of 6. That's the distance. Okay, so yeah, so hopefully you can enjoy this video, and thank you.